Hello. So you need to, we are interested in this question, um, and translate this question into an equation. Then you need to calculate probability that x, random variable x, smaller than or equal to 32,000. And we know x is non-standard normal distribution. So we hope to transform x into x minus mu over sigma. So this will be, in the end, a standard normal distribution. So we know how we change what we do on the left hand side, and we have to follow the same transformation on the other side. So subtract the mean and divide by the standard deviation on the right hand side, and you can calculate that. Mu is 35,000, denominator is 5,000. So the right hand side simplifies to minus 0.6. So tire mileage smaller than 32,000 miles means that, so we may interpret this means that, so on average, a tire endures 35,000 miles, but suppose that your tire is lasting only 32,000 miles. That means your tire is below average. How much below the average? It is 0.6 standard deviation below the average tire. So minus means below average, and 0.6 means the distance from the average in terms of standard deviation. So anyhow, you just need to look up this probability from the standard normal distribution, CDF. You may use whatever you use, and just replace. In the previous exercise, we had 1, but replace that number into minus 0.6. Then you will get 27%. So 27% cannot last more than 32,000 miles. So this is how we use the standard normal distribution and standardization of normal distribution to obtain probabilities. And okay, that was the first type of probability, and let's think about the second type of probability, where we are interested in probability x is greater than 30,000 miles. Greater than something. So it's greater than something, but still the idea is the same, because we are going to apply standardization. Standardization idea is the same. X will be transformed to x minus mu over sigma, and the other side will be transformed in the same way, 30,000 minus mu over sigma. And left hand side is known and replaced by z, and the right hand side can be calculated, which is minus 1. Right? So this is the regular standardization. There is no difference. The idea is you have to keep the inequality equal, same as before. So transform both sides. And then in the end, you need to calculate probability z greater than minus 1. Standard normal distribution greater than minus 1. A problem here is that this is not a cumulative probability. You have to have another step which converts this probability into a cumulative probability. So you need probability z greater than minus 1, but the CDF, the normal distribution table, has probability z smaller than minus 1, because this is the cumulative probability, smaller than something. So, but they have, you know how they are related. So probability greater than something equals 1 minus probability smaller than the same thing, right? So they are complement each other. So So you may use this this relationship and then find this guy. This is a cumulative probability. So you can find this probability from the table or from a calculator. So look up this number and then you will get 15.866%. So then just plug that in, then you get in the end 84.134%. So probability longer x greater than 30,000 miles is 84.134%. Right? So that is how we apply the standard normal distribution again. And this is another exercise for you. Idea is the same, just it's less like a probability lasting more than 37,000 miles. Basically, only the numbers change it, so everything else the same. The idea is the same. So pause the video and try it by yourself. Right? Okay, I believe you have done. So let's do it together. More than 37,000 miles can be written in this way, right? And transform, like left hand side is automatically z, but right hand side is also same, takes the same transformation. So you have to calculate this guy, which results in 0.4, which means 37,000 miles. So remember, the average was 35,000. So if a tire lasts more than 37,000 miles, it's above the average. So how much above? 0.4 standard deviation. So it's better than the average, but the distance from the average is 0.4 standard deviation. That's the meaning of this standardization. And then again, the same problem here. It is not a cumulative probability. It is greater than 0.4, not smaller than 0.4. So you have to convert this into this form. So this is a cumulative probability. And then you can find it from the calculator. So find this part and plug that into the relationship. Then you get the final, the probability you wanted. So these three steps are like basically the two key steps are standardization and using a calculator. So and just you just need to. So in the end, the ultimate goal is to fit a non-standard normal distribution into the CDF of the standard normal distribution. That's what I'm showing you here. By the way, I had maybe I need to mention this. In case some of you may know how to calculate, like in a program or on Excel or in your calculator, you may be able to calculate the probability of any standard, any non-standard normal distribution without by simply putting in parameters. There are actually that simpler way. That's not bad. That's you will get the same result. But the reason why I do not use that is because anyhow you have to understand standardization process. So practically you do not need standardization to simply calculate the probability, because computer can do that for you. Of course, computer formulas, there are formulas that automatically standardizes the random variable, the probabilities. But the process of standardization is very, very important for our later chapters. So therefore, I intentionally teach you as if this is the only way to calculate the probability. but actually not. Like the computer can calculate standard normal distribution, they can calculate any non-standard normal distribution. I'm telling you, if you know how to do that, do that. You do not need to like standardize every time you do the homework or like calculate any like normal distribution later if you need to use this. But anyhow, though, still what's important is understanding of the standardization process. That process is important because we are going to standardize every random variable from now on. So in the later chapters, we are going to standardize almost everything we have. So like just in case if you do not understand why I'm detouring, I'm teaching you a more cumbersome way to calculate a probability. Yes, it is not efficient way, but there is a more convenient way using computer, but I have to teach standardization process, and this is the best way to teach that. So please understand. Okay, and the third type of probability, third format of probability we may be interested in is like this, between 2 points. The probability between 30,000 and 40,000 miles. In this, still the idea is the same. Standardize and use the normal distribution information, standard normal distribution information. But so let's do it together. So probability between 30,000 and 40,000. Standardize x this way, and then remember we have to standardize its counterparts on both sides, right? So 30,000 should be standardized in the same way, and 40,000 should be standardized in the same way, because there are two inequalities. You have to maintain all the inequalities the same. So you have to transform every counterpart in the same way. So that's the basic idea. And then, mu is 35,000, sigma is 5,000. So plug in the numbers, calculate this guy, and you get -1 from 30,000 and +1 from 40,000, right? So one standard deviation below the average is 30,000 miles, and one standard deviation above the average is 40,000 miles. So after standardization, you get this. And then another step, this is not a cumulative probability either. So you have to convert this in this way. So difference between two cumulative probabilities. Cumulative probability up to 1 and cumulative probability up to -1. And their difference will give you the probability between those 2 points, right? So, and then you have to use the calculator twice, because in the first time you have to find this probability from the calculator, and use the calculator again to find this probability. So then in the end you will get the probability as their difference, right? So this is how we calculate this type of probability. Okay, then I will leave this for your exercise. Try this question, and as usual, continue to the next video after finding an answer to this question. Okay, see you in the next one. Bye.